What I'd like you to look at today in class is similar to the activity we did on Monday, where you're taking a more complicated expression and you're using your identities and your trig functions to simplify down to an easier expression to work with. One of the clues that one of the suggestions is when you're simplifying trig functions, sometimes it's easier to express the expression in terms of sine and cosine than to simplify. Sine and cosine are like our most basic trig functions we have, so if you can get it down to the most basic parts, a lot of times it'll simplify much easier. For example, if I took this problem, sine of theta times cotangent of theta, I would take the parts that weren't in terms of sine and cosine and rewrite it using my identities. The sine I'm going to leave alone. If you want to put it over 1, that's fine. I'm going to use my quotient identity and rewrite cotangent as cosine over sine. Then when I look at the problem, you'll notice that sine and sine will cross cancel, and this whole expression simplifies down just to cosine. Another example, if you look at example B, tangent times cosine times cosecant. The tangent I would rewrite as sine over cosine using our quotient identity. Cosine is already a basic building block. I'm going to leave it alone. However, if you do want to put it over 1, that's fine. And then cosecant, I can use my reciprocal identity to rewrite that as sine 1 over sine. Again, after you've rewritten in terms of sine and cosine, if you look at your basic parts, you can cross cancel the sines and the cosines, and this expression has a value of 1. Now, this doesn't mean that you have to do this all of the time. Sometimes, if there's an operation in the problem like this one, cosecant plus 1 times cosecant minus 1, you may want to work with the problem as it is first and see what happens. For example, I recognize this as a problem where I want to double distribute or use the FOIL method. And so when I do first, outer, inner, last, here are the terms that I get. Well, how that helps me, what I notice is that I have a negative cosecant theta and a positive cosecant theta. Those will cancel each other out. And then what I'm left with is cosecant squared minus 1. If you look back at your identities, what you'll notice is this is a manipulation of your third Pythagorean identity, which was 1 plus cotangent squared equals cosecant squared. However, if I subtract the 1 and get cotangent squared by itself, that is equal to cosecant squared minus 1. Going back to our problem, what that really tells me is that this expression is the same as just cotangent squared. One term is definitely simpler than 2. So I'd like you to try this technique on the problems that are on the 5.1 worksheet that is attached on Blackboard. Please just look at the worksheet on Blackboard and complete those problems on notebook paper, and we will answer any questions on Thursday when I get back.